that if we return the data modulus 2 is equal to 0, we return true. Otherwise, we returned undefined, which is a falsy value. If you wanted to be a little bit more explicit about this, you could say else return false. And this will give me just the list of even numbers. It passes first 1 into this function, and if it returns true, it includes 1 in the even numbers array. We pass in 3. 3 doesn't pass this function, so it's not included in the even numbers array. 2 does pass this function, so it's included in the even numbers array, as is 10, but those would be the only 2.
Eric, could you just return, or could you just do an arrow function and just put data mod 2 equals 0?
Mm-hmm. Yeah, you could totally reduce this. So we could say, let's do that. So grab the whole thing. And so we could say data modulus 2 is equal to 0. That's another way you could write it. So those both work. But what I want to show next is that we still keep those 2 arrays the same. We're just making other ones. So let's go ahead and bring back this, open up our console, paste that in there, and you can see the even numbers are just 2 and 10, but we haven't changed the original array. Those are all still there. We're just getting a subset of those. We're getting less of them. They're being put into this new array, all the members that match the criteria, which is, hey, if we take you modulus 2, do equals 0. If we divide you by 2, is there anything left over? If there's nothing left over, we'll include you. Otherwise, we won't. Next, we have this other function called isPrime. And what it does is it checks if a number is prime or not. So we're going to use the filter function to do that. So I'm going to start out with my original array dot filter, and then I can just say isPrime by itself. Now, and I'll say const prime numbers equals, and then we'll console.log out our prime numbers. Let's see if it matches that criteria. Oh, we forgot to put the isPrime function in there. Let's try that again. Prime numbers 2. We can't have the same thing in there twice. There we go. So 3, 2, and 5, prime numbers. 1, not a prime number, believe it or not. And then 10 is, of course, not a prime number either. Now, if this feels a little bit weird to you, you could always write it out like number is prime number, where you're taking the number and calling it directly. But you can see that calling this is basically just the same as calling isPrime. So we just have that function. Next, let's write a filter that runs through the original array and creates a new array containing only numbers larger than 5. So we'll say const more than 5 equals original array.filter. Let's take the number, and then what? What comes next?
Number greater than 5.
Numbers greater than 5. What do we expect to see in this array?
Just
One number.
10.
Yeah.
Yep. Should just be 10. Already declared more than 5. Why is it on there twice? There we go. We'll put an underscore in there. Otherwise, it might read as more than 52. So cool. Only 10. So what we're doing is we're passing in a function. It's almost like you're giving instructions to someone, and then they're doing something with the result. So you might use the analogy of, hey, I'm going to pass off these set of instructions to a task runner for me. I've got someone who I've hired to work on my behalf and go run errands, and I say, here's all the tasks I want you to do, and then they come back with all the results of performing those tasks. Or I might say like, hey, go ahead and here's a set of instructions. I want you to go through and sort all of this stuff like you're at a recycling center. And so you say, I want you to go through this pile of garbage and I want you to pull out all of the plastics and just have the plastics. Now the analogy is not perfect because that would in our analogy, you would actually be removing it from the original versus in the computer science version, it would just still be there. You'd just have a copy of it. You'd just have the plastics there. So it's a little bit there. Let's go ahead and do map at this point. Now map is a little bit different in that it'll give us an array of the same size, but they'll be changed in some manner. So in this case, the doubled array returns everything times 2. If we wanted to do this as an arrow function, we could do the following. Take off the function and put in the arrow. Take off the parentheses because it's just one parameter and it's just one line. So we can return data times 2. So we take in whatever the number was before and return in whatever it is times 2. We want to do that same thing for the tripled array. So we're just going to do that times 3. We're going to change one of these original arrays to be odd or even. So const odd or even equals this. And we're going to say in the longhand version, if data modulus 2 is equal to 0, well, that's even. So we'll return even. And if it's not, we'll return odd. You could also compress this to just use the ternary operator if you wanted. And it would look a little bit like this. To 0 question mark. So these two do the same thing. Questions over map or any of the other ones we've seen so far?
So filter, you always will have to return a Boolean, or it always has to be true.
Filter will always use whether the value is truthy or falsy, and so it's best to return true and false to make it clear. But every value is truthy or falsy, and by that it just means what happens when we try to force it to be a Boolean. Which way will it go? Will it go into true or will it go into false? Truthy values go into being coerced into true. Falsy values go into being coerced into false. And so there's a great thing you can Google, JS truthiness table, and this will tell you how they go. So this is for the single or the double equal signs. You can see that the triple equal signs is a lot easier. but it's still not a straight line. For example, an array doesn't equal an empty array doesn't equal an empty array. An empty object doesn't equal another empty object. Not a number doesn't equal itself, etc. So it'll help you if you need to do any comparisons to know, hey, which one it is. You can see this is why we use the triple equals a lot, because it makes it a lot easier. Because we don't have to think about all these edge cases. So for example, false is double equal to 0 in quotes. Weird, right? This is why people don't like JavaScript, or one of the reasons. Because that seems difficult to work with, but you can actually take advantage of it if you know what you're doing. But usually that's a bad idea. Being clever usually causes more trouble than it's worth when it comes to code. Cool. So you use maps and filters quite a bit, and often you'll use them in combination, where you might filter down a list of things and then use them. So for example, you might say like, I want to get a list of patrons, and then I want to map them to how much alcohol they bought over there. So I'm going to filter down people that are just over 21, and then I'm going to use map to see if their ID shows up in a list of, hey, who bought alcohol, things like that. So you'll often use map and filter together to either reduce down a list afterwards or reduce it down ahead of times, and then change up the data that you're working with, oftentimes working with another set of data that you're using. Cool. Now, next on the ES6 tour, something I've talked about on occasion is template literals. And template literals are there to say, hey, I just want to write out something. But if you're using a string, it has to all fit on one line, and adding different strings together means I have to use plus. And if I have some variable in between, it kind of makes the formatting weird, and then I have to do things like remember to add in tabs and new lines and different things in order for it to work. And sometimes it would be nice if I could just literally write what I wanted. Literally write if I wanted, and that's what template literals are for. And they also let us embed values in them. That's primarily how we're going to use them. They can do some other stuff too, but we're not going to dive into that. If you're curious about it, you can come ask me during office hours. So let's look at this. We've got Arya. My name is Arya.first. I'm loyal to Arya.allegiance. Console.log out this greeting. So this is a template string. You can tell because it's got backticks. This isn't an apostrophe or a single quote. This is a backtick. It's on a Mac keyboard. It's sort of on the top left. It's probably in a similar position on yours. Shares a key with the tilde key, which is the one that looks like this. Sure. So that's what it is. This is the beginning of it. This is the end of it. And unlike using double or single quotes, you can do line breaks. You'll notice that the beginning backtick starts here and the ending backtick is here, versus if I try and do that with a string, it'll say unterminated string literal, which means, hey, these need to both be on the same line for these to work. Same thing with single quotes. So that's one way that it's different. The other is that this new line that I typed in here will actually literally show up, hence the name template literal. So we're going to clear all this out, put all of this in here, and you see that we actually have two lines, just like we wrote it here. So if it encounters a new line that you wrote in the editor, it's going to include that new line. The next thing is we want to actually interpolate values. We want to say, hey, go ahead and I want to put a JavaScript expression in here, not a statement, but an expression. And we'll talk more about the differences between that sometime in the future, probably during an office hours. So my name is aria.first, I'm loyal to aria.allegiance. So whatever aria.first is and aria.allegiance is, the name Aria, the allegiance to House Stark, those are placed there. So this is a pretty cool way of allowing us to embed things. So I want to jump ahead and look at that really quick. Cool. So a great candidate for this is HTML. Wouldn't it be nice if we could just start writing out what the HTML should look like, rather than just having to manually construct it by doing things like document.createElement, etc. So for this next activity, we want you to try out template literals, and we want you to, let's take a look at what this turns into. The less I know, the better. Tame Impala by the Currents. Cool. You'll notice that we don't have that to start out with. That's just being put on the page. So what we want you to do here is to come up with a piece of music. In our case, that music is The Less I Know by the Better, Tame Impala Currents. So it's going to have a song title, an artist title, and the album it's off of. And so you'll need to include that on your music. And then we want you to build the rest of the HTML based off of this. You don't need to change anything here. All of your code is going to go between here and here. So you'll just be filling out the song snippet variable and the music variable. The rest of it is already set up for you. We're going to be working on this for 10 minutes. If you have questions along the way, let us know. We'd love to help you out. Good luck. So first of all, we've got our music here. Uh-oh, it looks like my camera froze, at least on my end. Weird. Give me just a second.
Yeah, we can hear you, but can't see you.
How about now?
Yep.
There we go, much better. Weird video stuff's been happening today. All right, so first and most important order of business, let's choose a song. What song do we want to use?
Hotel California.
Hotel California. And is that the Eagles?
It is, yeah.
Yeah, it's the Eagles, and I don't know. I'm guessing that it's off of Hotel California. Or is it something
not really
else?
Sure. I think it's off Hotel California.
Yeah, let's find out. There we go. I guess, yeah, it's by Hotel, it's Hotel California. So let's go with title. No, that's going to be in my head for a while. The artist is the Eagles, and the album is going to be Hotel California as well. Cool. So we have our data in place. This is what represents it. Maybe we're getting this from an AJAX call. Maybe the user input it. The point is we have this object. And what we want to do is change it into some HTML. So let's start by just writing out the HTML inside this template string. So I would say something like h2, whatever the title is, and then I would have a p tag. We'll give it a class of artist. And you'll notice it's very easy to write the double quotes because we're not using them to designate strings. So when we're including things like this, it becomes a lot easier. And then we would say, hey, this is what we want the artist to be. And then we would do the same thing for the album. And we could just say, all right, does this work? So even just as a way to dynamically put content on the page, this isn't bad. And even when we're generating HTML files to send back to the front end, we'll still be able to use techniques like this using template strings. So title, artist, album, and we say to ourselves, that's pretty close to what we want, but we want to put the actual values in there. So we use string interpolation. So I have this title, and then I say $, left curly brace, close, right curly brace. Curly brace. There we go. Words, right? Now, what value needs to go here? If I was just going to access it like it was JavaScript, what would I put here?
Music.title.
Music.title.
Yeah, music.title. And we would do the same thing for the other pieces here. So very often it's good to just write out what you want the HTML to be and then substitute in the different values that you want. Now, if I come back here, refresh the page, it has that data in there. And if I swap out whatever this is, if I say Hotel Nevada, the song that they came up with, which was way less successful until they switched it at the end, I guess. That's not true. Let's go ahead and refresh the page, and it changes. So now I have a way to convert this this function almost, where I can convert some piece of data into HTML for that piece of data. And that idea is very, very powerful of let's take this input, and this input will be able to just directly create this HTML as a result of that. Well, actually, this is actually one of the central ideas that React is built upon, and we'll be looking at that more in the future. It just does, and it uses a technique like this, but it also has a lot more complicated pieces within it. But this is very important idea, and this is a very easy way to author and write this kind of stuff. Could you do this with just plus signs and the different /n's and everything else? Yes. There's nothing new that you're able to do as a result of what we've seen here, but it's way easier to express and it's way faster so that you can get, it's very easy to comprehend what's going on here rather than a series of plus signs and having to escape everything all the time. It's much better. Cool. All right, so the next thing, we're going to switch gears and go to another ES6 feature. We're going to jump past the for of loops. We might cover that during office hours if we have time, but I want to jump to some of these other ones that are a little bit more important. So, as you might have seen us do, when we console.log something, we can actually console.log out as many different things as we want. So I could be like, hey, I want to console.log out A to true, and it will just spit them all out. I can feed as many arguments to console.log as I wish. And you might say, hey, I want to be able to do that. I might want to have an add function where I want to be able to add 1, 2, 3, 4, 5, etc., as many arguments as I want, and it'll just add them all together. Now that can be kind of hard to do. Now you could make it so that you passed in an array, but then you're kind of just unnecessarily creating an array, or you're making the user put things in an array just to do that for you. And we want to avoid that. So we're going to use something called the rest operator, as in go get the rest of them. So let's take a look at that. And its corresponding spread operator. They're both 3 dots, but depending on their context, they do different things. And so we'll start out with this one. So we've got this function called add, and we want to be able to add all of them together. So instead what we do is we say dot, 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 that's the rest operator. And it's a rest operator because it's in this function parameter list. Go ahead and however much people type in there, we're going to treat as a array called nums. And then we just go through each one, add them together, and return the sum. So let's console.log out what nums looks like at this point. We'll go ahead and copy this. So there, that's add. So if I say add and I don't give it anything, nums is a empty array. If I say add 1, 2, 3, the nums are 1, 2, and 3. So what it's doing is it's taking any values I get separated by commas and just saying, let's just group those together into one big array called nums. Now, the reason it's called the rest array is because you can also combine this with other ones. So let's say first and nums. And we'll go ahead and put these on different lines. So we're updating our add function real quick. So if I say this one, and I say add 1, 2, and 3, the first number is 1, and then nums are the rest of them. The rest operator always goes at the end. So you can't flip these around. You can't say dot, 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 nums, and then say last, for example. In fact, it'll give us so if we do this, at least I don't believe so. Maybe they changed that since last time. Let's look. Yeah, didn't think so. So the rest parameter must be the last formal parameter, meaning nums always has to be last because it's going to grab everything after that point. So after all your formal parameters, like first in this case, anything that you write after that gets brought into the nums array. And so this is a way that you can group together a bunch of different things that people give you, but not force them to put them into arrays for you to use. You can just literally put them in there. So it's a little convenience feature in that regard. Let's look at it down here. So you can write a function called how many args. And this is just going to tell you how many things are there. You can see we're using a template string with the backticks, and then we're embedding args.length in there. So if I have this function and I call how many args with nothing, it'll say you passed 0 arguments. If I say ASDF 234, it'll say you passed 2 arguments. Again, it's just an array of those items. Now, that's dot, 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 and it's the rest operator when it's in this argument list. If it's not in the argument list, if it's inside of a object definition or an array definition, the 3 dots are something else. And they're called the spread operator. And rather than grouping things together, they spread stuff out. So what this does is if I've got dragons, Drogon, Viserion, and Rhaegal, and then I've got these weapons, Dragonglass, the 3 dragons themselves, and then Wildfire, let's go ahead and console.log this out. So you can see here that this actually takes each of the members of dragons and just spreads them out each as an individual member in this array. So Dragonglass, then the 3 members of dragons, and then Wildfire. So this allows us to sort of take an array, and if we didn't include this, for example, let's refresh the page, and let's just take out the 3 dots. You can see that in the middle, we now have this array of them embedded rather than just the members of them embedded in the array. So this lets us kind of flatten something out so that it's not just, hey, an array, and sometimes there will be an array embedded in that. Instead, we're putting everything together on the same line. You can do this with objects as well. which we saw a little bit ago with the map function, where it'll take each one of the properties of the object and split it out. So what we want you to do is to take some time and do your best to work with this. It's okay if you're having some trouble adjusting to it the first time. Getting used to it the first time takes a little bit of work, but you'll find that you are sped up. It's easier to manipulate and work with data once you've gotten more and more practice doing this. So inside of here, we've got a couple of different songs. We've got Creep by Radiohead, Everlong by the Foo Fighters, Bulls on Parade by, I'm blanking on the name right now.
Rage Against the
Rage
Machine.
Against the
That's it, Rage Against the Machine. Song 2 by Blur, and What I Got by
Sublime.
Sublime. All right, cool. So that's the songs array. And so copy the songs array into another array using spread and console.log what it returns. So you're not going to be console.logging out songs, you're going to be console.logging out something else. Go ahead and make your own songs, call it like my songs, and add in a couple of different ones, but make sure that you include all of those in the list using the spread operator, like we saw being used here with dragons and weapons. Other thing that you want to do is modify this function so that it uses the rest operator. Relatively straightforward, but you'll see 3 dots on line 9 if you're doing that correctly. You'll also need to make a few other modifications than that, but not many. Won't have to change very much. Cool. So we're going to give you 10 minutes to work on this. If you have questions, let us know. We'd love to help you out. Good luck. Any questions? Reduce here is another array method, and it's a way to, we'll talk about it more in the future sometime. If it comes up, it doesn't get used as much as map and filter, but it's a way of doing things like sums, but more generically. So if you wanted to be like, hey, I want to count up how much alcohol everyone has had at this party, and you've got an array of people, and one of the fields is how much alcohol have you had, then you could use reduce to do something like that. But we're not going to go into too much detail more than that on it. Cool. Next, we've seen sort of this pattern of putting things into a structure with the rest operator and taking things out of a structure with the spread operator. We sort of largely refer to this as structuring and destructuring, which is where we either put things into a structure or take things out of a structure. And we've looked at that mostly with arrays at this point. So next we want to look at this with objects. And this will be one of the last things we probably look at before lunch today. So in this case, I've got some object and it's kind of complicated. And I've got Jamie. And so we've got Arya and Jamie, and you'll notice that the structure is the same. They both have a name and then they both have a parents array. So I could access Arya's name by saying arya.name, or I could say Arya parents is equal to arya.parents, and that'll print all of this out. In fact, let's go ahead and begin with that. Let me make sure I've got one of these handy for us. We'll close this out, put this here. So there's Arya. And you're used to doing things in this way. It's an easy way to get values out of an object if you don't want to reference the whole thing again. But sometimes we want to just grab those pieces, especially if I wanted to say something like const name equals aria.name, right? Like I'm writing name on there twice. That just seems excessive. So instead, and I'm going to have to refresh the page to do this, because I'm going to say const, and then I'm going to say the pieces that I want to pull out of the array, of the object. And I'm going to say that they're in an object by saying, here's an object equals aria. It's almost like, hey, within this object are going to be some fields. So if I say name, like so, what this code does is it says, oh, aria has a property called name. I'm going to set something called name out here and pull that value out. So now name is Arya Stark. I can do that same thing with other fields as well. If I do it with parents and I look at what parents is, it'll be that array. If I try and do it with something that doesn't exist as a property of that object and I just say ASDF, guess what? ASDF is undefined. So it doesn't throw an error, but it doesn't give me any information either. So this is a way that you can pull that information out. Now, if you want to, I could say, hey, I want to use name, but I already have something called name here. Let's say that we did that with Jamie, for example. I want to use name here, but I've already got something in this scope called name, right? So that's problematic. How do I destructure it? Well, you can say, yeah, the property is name, but could you rename it something else, like maybe Jamie name? And now if I look at what Jamie name is, it's extracted out that way. So it's takes some getting used to as syntax, but what this lets me do is it lets me extract out the pieces that I need, and I'm not writing like name equals whatever.name, and you can actually nest these many levels deep. When you get into more complicated objects, you're going to actually see a lot of destructuring in modern web apps. People use it quite a bit. So one thing that you could do, and we'll go back here, is if I wanted to log out a character's parents, let's do that with Aria right here. I could use this function. So let's clear this out, put this here. Arya's parents are Eddard Stark and Caitlin Stark. So we could do better than this. Let's use a couple of different facets, and let's use a template string to help us out here. So I'm going to write a better log function. So const better log function, or better log character. And so something that you can do is, rather than giving this the name character, what you can do is destructure out the parts that you need immediately. So let's go ahead and copy what was there before. In fact, let's do that. Let's do this here. And I'm going to do it slightly different than they do it along the way. But let's sort of watch this transformation. So we could say something along the lines of const name parents equals character. Like so. But then you'll notice we're just using characters so that we have something to reference here. So we can actually destructure the parameter directly so that we don't have to include this extra line. Another thing that you could do is further split it up into different pieces of an array. So you could even say, I think, parent 1, parent 2. And then we could say console.log names parents are parent 1 and parent 2. And then we could just put that all as one line. And because
And it knows you're referencing Arya because of the log character Arya down there.
pardon? So
And it knows
yeah,
your-
log character Arya, what is going on here is we expect two properties, one called name and one called parents. We also expect parents to be an array with two members. The first one we're labeling parent 1, the second one we're labeling parent 2. So this has expectations about what the object that it get, how it's structured. And it sort of splits out pieces of those structure so that the rest of the function doesn't need to care at all. So it just sees name, parent 1, parent 2, and this piece is what's destructuring those pieces, going into that structure and plucking out the pieces that it wants, which is really what destructuring is all about. Now, you didn't have to do that extra level that I did here. You could just say parents and then use parents 0 and parents 1, but it's a pretty cool little example. I'll go ahead and post this one in Slack. This is kind of the most code golfy of it. Again, if someone sent this to me in a pull request, I might go, seems a little too clever for our own good, but it's good to be able to read it. So I'll post this in class activities. And so when we call log character Arya, all of that's going to work. So but that's kind of an advanced case. The big level of destructuring you're mostly going to encounter is something like this. And then you might do that with the parameters as well. So you don't necessarily have to do a multi-level destructure, but it's a good way to do it. Cool. So for this next one, what we want you to do is destructure Arya so that you get first and last. And then what we want you to do is destructure out brother 1 and brother 2. This one is a multi-level destructure. You can do it in one statement, but it's okay if you break it up into multiple statements in order to get brother 1 and brother 2. We just want you to use destructuring to do it. And then finally, we want you to do the same thing with name, alias, and allegiance. That would be Ned Stark is the name, the Quiet Wolf is the alias, and House Stark is the allegiance. Same thing with skills, except it's a string, so you're going to have to do a little bit of work first. This is going to you're going to have to turn this into an array somehow and then destructure that array. So we're going to work on this for the next 10 minutes. Then we'll break for lunch. After lunch, we'll go through it, and then we'll start talking about some other stuff that you can do on the back end and introduce some other cool packages for us to use. Cool. So we're going to work on this for the next 10 minutes. Good luck.
You muted.
There we go. All right. So came back from lunch. Kat was sitting on the keyboard. Hopefully didn't change anything too drastically, but won't be able to tell for sure. So welcome back, everyone. Hopefully you had a great lunch. I did. And now it's time to get back to coding some JavaScript. So when we left right before lunch, we were talking about destructuring, sort of the ability to pull things out of these more complicated JavaScript structures in a succinct way. And we started with arrays beforehand, and then we wanted to get a little bit of practice with objects as well. So we're going to practice it with some of these different pieces that we have here. So for some reason, I'm getting the spinny beach ball of death on some of this stuff. All right, so let's go through these activities together. So the first one is first. I want to destructure this first value out of the ARIA object. How would I do that?
You could use const and then 2 curly braces and then first, last, origin, allegiance. You just wanted to destructure the whole thing.
Yeah. In this case, we just need first and last for these two. So you don't have to destructure the whole thing. You can just pull out the pieces that you need. But if you wanted origin allegiance, you could absolutely do that as well. So first, last equals ARIA. And so now we see ARIA in Stark. If we run this, let's go ahead, copy this into this really quick. Oh, and we already declared that, so let's refresh the page. And then we get ARIA and Stark. Awesome. Cool. Next, we've got John. First, last, title, family, brothers, brother 1, brother 2. So this is the one that we want to get. So we could do something along the lines of const brother 1, brother 2 equals what?
My guess was John.brothers, but
John.family
Family dot brothers.
dot brothers. We've got another level in between there. Now, if we also wanted to get the sisters, we could do that as well, but by destructuring from the family and then pulling out the brothers component. So we could say another level in here, brothers 1 and 2 is another way you could have done this, where you're pulling out brother 1 and brother 2 from brothers. And at that point, you could also pull out from sisters, sister 1 and sister 2. So if you need to mix levels like that or do multiple levels, you can actually split it up into multiple pieces, but that can be a little bit tricky. So we're just going to go with the simplest version. Don't overcomplicate things and do it like this. But you can start pulling out huge things all from the different structures. Cool. Next, we've got characters. So I need to say const, and this one's going to be a little bit different because we're going to use brackets and then put the name of what we want to destructure in the position. So we're going to say name, alias, allegiance equals characters. And what this does is it just corresponds to the order. So this is going to get the first element. This is going to get the second element. This is going to get the third element, etc. So the names here are a little bit more open because we don't have to match a property name. It just cares about what the position is in those particular cases. Now, if we stack that on top of what we're doing here, we're going to need to say const and then destructure some of the different pieces. So this is going to be equal to skills.split dot map t dot trim. And so what that does is this gives us an array of the usurper. So let's go ahead and just call this skills array, and let's console.log that out. So we say skills array, and that gives us each one of the pieces. Where if we forgot the trim, we would have some white space at the beginning. This allows us to get rid of the white space on either side. And so what we're going to do is destructure this and say const, and in fact, we could even replace skills array itself with this, with alias, gender, family, and spouse. So we can split like that, or we could split with these two characters, and then we wouldn't have to trim the whole thing. Just depends on how you want to do it. Questions? So as you can see here, this allows us to, if we get really skilled with structuring and destructuring, it allows us to very easily pluck out the pieces we need in one fell swoop. This way we don't have a lot of this or new variable equals something dot something dot something dot something, new variable 2 equals something dot something dot something dot something. We can get them all at once, and it makes it easier to grab them. But it can be a little bit more complicated along the way. Cool, cool. All right. So next thing I want to do is, we've already seen a bunch of use of callbacks at this point. And we've seen them, and you first got introduced to them with event listeners. When we had callbacks, it was in response to some event. So some event would happen, and then we would specify to the computer what would happen. We also learned about this when we would make AJAX requests. We would send off a request, the system would bring us back data, and then we would tell it what to do with data. We saw this with set interval and set timeout. And all of these were asynchronous events, but we can even use callbacks for synchronous items, like we saw with map and filter, where we told it what to do. Those were still synchronous, but we wanted to have it be sort of modular, what they would do with any given results. So a callback is a function that we pass as an argument into another function, which is then called by that function. Let's call that function A, that we pass in to function B, which is then called by that function B. So we pass A into B, and then B calls A. Very simple thing that we could do here. We could say function do something, and then we put a function there. And all this function does is gets called. So do something just calls that function immediately. This function is a callback. And so when I call, say, do something, and then I give it a function of something to do, and it says console.log hello, this function right here is the callback. this is the function A that got passed to the do something function B, and function B is then calling that function A, or which we've labeled fn. So this is the callback. This is the callback definition. So we're saying, hey, when call do something and run console.log hello. Now, a lot of times they'll actually give us something. So it's if I say do something with 5, and I call this function with 5, I could call do something with 5, and then I could say value, and then I could write four plus value is so in that way, oftentimes these other functions have values that they need to pass to us. The event listeners are passing not the number 5, but information about the event that just happened. The Ajax response is passing in not the number 5, but the response that it got from the database service or from the server. The set interval is actually not passing in anything. And our map and filter functions are passing in both the item that we want to use on this current loop and the index on the current loop as well. So these callbacks are being passed information from other parts of the program. And so when we want to just swap out that piece, when we want to give certain instructions, we add that on top of it. Think of callbacks as like when you add custom instructions when you're ordering a pizza. You're like, hey, by the way, I would like it if you could throw in a couple extra bags or things of red pepper flakes. Cool. You're already getting the pizza. They're providing the pizza. You're not telling them how to build the pizza, but they offer you the ability to maybe modify the pizza a little bit more than you might typically say. You say, hey, I want a pepperoni pizza. They say, cool. They provide all of that. And then in the extra request section, you could go, and if you could throw on some extra red pepper flakes, that'd be great. That's kind of like your callback function. You're telling them what you want them to do with the pizza before it gets to you, things like that. So let's go with some practice. So in this case, we've got a file called animals.json. We've got ones about Mittens, Fido, Wally, Sasha, etc. All of these different animals, and they all have the same structure, including their name, their species, their age, their gender, etc. What we want you to do is parse the JSON string to an object and then create 2 new arrays to contain the cats and dogs objects. So you can change any of this code that you might need to, but try and think of some of the functions that we learned today and use the callback. You'll be writing your own callbacks in order to make this happen. And then go ahead and just console.log out the dogs and the cats afterwards to make sure that you got them. So you'll be writing your own custom functions based off of the data. Highly encourage you to start by console.logging out the result of the data from reading animals.json. This is its own callback right at the beginning, and then proceed from there. Cool. There's more instructions right here. It's taking stock of the file, explain to your group what's going on in the file, and then adding in your own custom code to achieve the objective. Cool. If you have any questions, let us know. We'd love to help you out. Good luck. Alrighty, folks, looks like everyone's piling back in. So we're going to go ahead and just review what we saw here. So we could also go ahead and try and spit this data back out into their own files. So let's see here, we start out with this. Let's go ahead and just run this. We can't, unfortunately, copy and paste this into the browser because we're using FS, we're using Node, so we need that here. So I'm going to go ahead, right-click this, open in the terminal. Fortunately, we're not using any external dependencies, so we don't need to have a package.json. We don't need to install everything. We can just run the Node program itself. So I'm going to say node index.js. And it looks like I don't have a cats one yet. Let's go ahead and fix that. Run that again. And we can see here's each one of these, and then I want to put them into dogs and cats. I'm going to go ahead, and because this is an array, I'm going to use a filter method to change this. So I'm going to take the animal JSON.filter each animal, and I'm going to return that the animal species is equal to dog. If it's the species is equal to dog, I want to include it in my list. You could also use object destructuring so that you would just say, hey, is the species equal to a dog? So that you didn't have to repeat animals on there over and over again. But that's fine. I think this is just as good. So let's run this again. We can see that our first list has dog, and then I wrote cats instead of cat, so we can see that there's an error there. That's one of the reasons we like to test this in small pieces along the way. So we've got dog and cats, and we've got each one of these. And something that we might want to do is we might want to say, I would like to just write these out to their own file. So I'm taking the animals.json and I'm going to make two smaller ones based off of that are just the dogs and just the cats. So once I have this, I'm going to say fs.writeFile. We'll call this one dogs.json. Again, it's going to be UTF-8 function error data. Well, actually, we aren't going to write UTF-8. We're going to write the actual data. So this is going to be JSON.stringify dogs null 2, and then we'll have our callback with whether it was successful or not. And so if there was an error, we will do what's called throwing the error, which is saying, hey, this is an exception. We're going to raise it as an exception. We'll talk about that more when we get into more in-depth error handling. But whenever you see the red text in your console, it's because an error was thrown and it wasn't caught. We'll talk about that more in the future. Successfully wrote to dogs.json file. And we're going to do the same thing, but for cats. Cool. We could even potentially make that a function, but it's only happening twice. That would be a little bit of overkill. Once it gets past 3 times is when my personal alarm starts to go off for, hey, maybe this should be a function, but just 2 is just fine. So let's try this out. We now get cats.json, where it has all of these different cats, and we've got dogs.json that has all of these different dogs in it from our source of animals.json. Cool. And you can see we use callbacks a lot in this particular program. We've got a callback from reading the file. We use callbacks in our 2 filter functions. We use a callback to write each one of those files out. So within this pretty small program, all told, we've already got 5 callback functions. So callback functions are everywhere, especially when you use them in Node.js. Just working with the file system, working with the network of any kind. Even on the back end, you're going to be using callbacks all the time. And the callbacks are kind of our first basic unit when we're working with things that are both modular in terms of their functionality, and also things where we want to potentially deal with asynchronicity or things that happen over time. These callbacks are synchronous. They just happen immediately. We don't wait for anything to happen. These callbacks are from asynchronous functions. It takes time to go to the file system and read the file. It takes time to write the file. So some of the callbacks are synchronous, some of them aren't. We're going to be looking at those in more detail. Now, one of the places that we saw that was network calls. And so when we were using jQuery $.ajax to access servers, that was one place we saw it. However, jQuery, as we saw, includes a ton of stuff specific to the document object model, and a few examples notwithstanding beforehand, we're still largely focused on the backend, which doesn't have a document to work with. So grabbing all of those extra pieces, including all of those pieces of code that we're not going to use, is kind of dead weight for a library to use. So we're going to introduce a new library, and this new library is focused just on making AJAX requests, just on making web requests. It doesn't have to do with all the DOM manipulation, and it's called Axios. Let's take a look at it. So Axios is a external package, just like Inquirer was. So we need to run npm install inside of this folder. So I'm going to right click, open this up in the terminal, and run npm install. Whenever I see a package.json and I don't see any node modules folders, I know that I need to run npm install. And so let's say node index.js. Oh, typed in too many J's. Let's try that again. So this talks to the OMDB, and it tells us a little bit about the movie The Matrix, and tells us some of the different information about this. An API we've used before. Let's look at how we do it specifically. We say axios.get, so rather than saying .make a call or .ajax and then saying the method as get, we call the get method instead. So we say go to omdbapi.com and get this information about the matrix. Here's all of the relevant information in the URL. And then once you have that, here's the callback for how to handle that information. And in this case, we console.log out the data that we get back. This res, often short for response, includes a lot of different pieces of information. We're only interested in the body of the response or the data of the response from this particular entry, but we could ask things like, hey, what was the status code, and other things about the request other than just the data that we wanted it to get. So we'll almost always be just using console.log res.data in that regard. So we want you to give that a shot as well. And then we'll start talking about this then structure with this concept of a promise object, or the idea that we have an object that encapsulates the idea that we will have this value later. We don't have it yet, but once you get it, here's what you do with it and how you can chain those things together. So before we do that, though, we're going to practice with just Axios itself. Then we're going to talk about promises, and then we're going to talk about async await time withstanding. If we run out of time, we'll just continue on it tomorrow morning. Cool. So you're going to need to run npm install. That'll install Axios and Inquirer on your system. Index.js, it says enter your GitHub username. And then, so once it's got your GitHub username, then it gets this query URL, and it's going to issue a request to the GitHub API to get your different repos. What we provide you the URL here, but the rest of it actually calling that API is up to you. You'll be using Axios to do that. Once you've done that, go ahead and loop through the arrays of the repos and save only the names. Just want the names. There's going to be a lot of different pieces of information that GitHub gives you back about those repos. We just want the names. And then join all of those together into a single string on a new line. And then you're going to write that out to a file called repos.txt. That way, you can just see, hey, here's a list of all of my different repos, one after another. Very similar to the homework that you're going to be working on, of this idea of, hey, let me go get this information, let me pull out the specific pieces I want, build the string, and then output it into a file for me to use. So from there, you should see a list of all of your GitHub repos, or anyone's GitHub repos. You could use mine, you could use other people in your groups for that. There's a limit on the non-authenticated requests to GitHub since you don't have an API key set up for this. So try not to just use a big for loop to hit things over and over and over again. Instead, you should just have one Axios call and then use all the data that you get back from it. Cool. All right, so we're going to open up the breakout rooms at this point as sort of a introduction to Axios and the GitHub API, which is also kind of cool. We'll be working on this for the next 10 minutes. Then we'll review it, and then we'll talk a little bit more in depth about promises, which is where that .then structure comes from. Cool. We'll see you in 10. Good luck. Alrighty, folks. So we've got this program. We're going to wait for everyone else to kind of pile in, but while we do, let's review what we got. We got FS, Axios, and Inquirer. Axios and Inquirer are packages that we have that aren't included, so we need to make sure they're listed in the package.json and that we npm install them. So I'm going to go ahead and open this up in the terminal and run npm install. Always my first step there. Next, if I'm not sure how to use Axios exactly, I can go to the Axios npm page. And from there, find any documentation. So if I go to npmj.org and I look for a library called Axios, we can find this exact match here. And you can see it gets about 9 million weekly downloads. It's a pretty popular library. And so this lets us work with different pieces. How to install it using npm or some of the other ones, or using a CDN. And then it shows us how to use it. Axios.get, some URL, then do something, catch, finally, all of these other parameters. If the documentation isn't working for you, you can also do Google searches for Stack Overflow and see if that can help you. Fortunately, we've got some exercises and solutions to help us go through it already. So we're going to start out by saying axios.get whatever this query URL is. And then we're going to take whatever we get back and we're going to console.log res.data. So let's see what we get. So I'm going to go ahead and run this. So node index.js. I'm going to go ahead and type in my GitHub username, and it's going to give me back a lot of pieces of data. Because we said, hey, limit 100 repos, and I have over 100 repos. So we get to see all 100 of those repos written to the screen. Now, we don't want all of this, we just want part of it. So if we come here, we can find some of the different pieces, like the name. So I just want the name. We have a big array of names. Another thing that you can do is, if you want to, you can also just copy this URL here. And we're going to make sure that you replace this with your username. Or you could, again, visit the documentation for it. So we can see that it just gives us back an array, and each one of those have a name. So I'm going to take this data that I got, and I'm going to start working with it. So I'm going to say, all right, const repo names equals res.data.map. I'm going to take in a repo, and then I'm just going to return the repo name in its place. This means I don't have all of the other data to deal with. Let's go ahead and console.log out the repo names at this point. So we'll run this whole thing again. As it goes through all of those, because I forgot to unconsole or comment that piece out, which we'll look at in just a second. Just has a lot of stuff it needs to comment out. And then here's some of my different repos. But this is just an array. I still want to output this to repos.txt. So if I try to do that and I just say, let's go ahead and say fs.writefile repos.txt, and I just say repo names, function error if error console.log error, or if error, we'll say throw error, otherwise console.log done. Let's see what happens. Hopefully it should be a little bit shorter because we won't be console.logging out 100 repos worth of stuff. So now it should just output about 100 repos or so after it's had a chance to visit GitHub and see each one of those. Cool. So we see repos.txt, and we kind of see it, but it's not formatted in the way we want, and it's got each one of, on the edge, if we go to one edge, it's just not exactly what we want. So it's close, but it's not quite what we want. So let's go back to the code, and instead of just saying repos.name, I'm going to say repo names.join with a new line between each one. The new line in between each one. And so let's run that again. And if we look in repos.txt, there they all are, one line after another. Cool. So let's look at this program and sort of talk about some of the different pieces and some of the different places where things are returning promises. And so if we think about all the different asynchronous parts of this program, we've got three main stages. The first one is when we ask the user for something. So we start up the user and we prompt the user. Nothing else is going to happen until the user responds. So that's our first sort of asynchronous moment. Once the user responds, then we move on to our second phase. This is where we try and talk to the GitHub API, which we can see with axios.get. And then once that's done, we have our final phase where we have the data, but we need to write it to the file. And then once we're we've got that, we're done. So whenever you have these asynchronous actions, what I like to do is kind of draw them as these circles with lines between them to see how you can get from one state to another. And these are great, these circles are great things to put into their own functions. So it's a bit easier to tell what's going on. And the great thing is that except for fs.writeFile, these other two are promises. So it's relatively easy to chain those two together. So let's do that. So what I'm going to do is we say, okay, I've got this function, and then I want to do this function, and then I want to do this one. So what I'm going to do is kind of break this up into a different piece right here. So I ask for this, and then I'm going to actually say return axios.getQueryURL. And because this is a promise, I can actually change the next promise after it. So then I can say dot then, so after I did this piece and I got back this piece, then I move on and do the rest of it. From there, I can take the result that I got back from this web request and move on to the next stage. Now this isn't a promise. Like, this is just a callback. We've got an extra one on there. So I can't exactly just pass this on to the next section. However, I could say just, okay, I've transformed this piece of data. However, there's not any asynchronicity going on here, so we don't care. But this is asynchronous. This happens after I write the file. There's some time that passes in between here. And fortunately for us, there's a way I can convert this into a promise. And so I'm going to use util to do that. And there's another, so const util equals require util. This is a library of utilities that gets associated with Node. It just exists there. And so what I'm going to do is I'm going to say, I would like to have a asynchronous promise version of this function. And you can do that as long as the callback follows this format of error, comma, data. If the last argument of the function is a callback and it follows that format of error, comma, data, then you can transform it using this function. So I'm going to say const write file async. This is just a name that I came up with. You could call it what about a bing bong, equals util.promisify fs.writefile. So I'm taking the write file function and I'm making it operate like it has promises. So with write file async, I'm going to return write file async repos.txt. My repo names .join these ends together. And then what happens afterwards is if that's successful, then I'm going to say console.log success. And if it wasn't successful, if any of these failed along the way, I'm going to use this statement called catch. Catch is going to say, hey, if there were any errors, what was it? So I'm going to console.log out that error. So now it's very easy to see the sequence of events. I prompt the user, then I make an Axios call, then I write that out that file, and then I'm done and the program exits. So each one of those is a different stage separated by these different then clauses, which we can sort of draw out as a series of circles moving from one stage to another. And we do this with promises. So let's talk about promises in a little bit more depth, but before we do, any questions on what we have right here? Can be a bit tricky. Promises are a little bit tricky when you first get into them. So if you're feeling like, wow, this is a lot of stuff, it is.
I'm not understanding the need for the constant of write file async when you're returning a write file async that's creating that repost text document.
Right. So fs.writeFile by default won't return anything. It'll let us use a callback, but we want to structure it so it's very obvious we're moving from one stage to another. So if we did it without that, let's go over to the solved version, which has it that way. We'd have to embed this function further in here. We'd have to embed this right here. But with a promise, we can sort of pass it off to anything and say, okay, cool, now what do you want to do? So this lets us keep it as a promise. So it's not strictly necessary, but it helps structure the program better. And you'll see that as we run into more and more examples.
Okay.
All righty.
Can you go back to your code real quick? The other one.
Yes.
I'm not the whole util.promisify just kind of all threw me for why was that there?
Yeah, it's to convert that from working with just callbacks to working with promises. And that'll make a little bit more sense when we talk about promises. That's a great question. It's a common confusion. It's perfectly valid to be like, yeah, that seems kind of weird. It is kind of weird. Like, that's normal. But you'll see, I promise we'll get to it where you'll be like, oh, okay, I get that. It just takes a while. It took me a bit. So I just want to sort of introduce you so that you start seeing it. So the way we have it, and so this is so that it returns a promise instead of just us using a callback by itself. So if we think about it this way, this is phase 1. This is phase 2. This is phase 3, and then we return back phase 4. And the big difference between a callback is we want to avoid something called callback hell. Let me go ahead and grab all of these different ones where we have a chain of things that need to go one after another. So as you can see here, this is a JavaScript program, and without even reading what it does, you can just see that it's sort of gradually moving further and further in and to the right. And it's sort of hard to start seeing what these different things are doing. So you're just like, yeah, we start out doing something, and then somewhere in here we start doing something else, and then somewhere in here we start doing something further. The readability suffers a lot when we are dealing with callback hell. And so promises are the first attempt to deal with something like this. Here's another common example of callback hell. Let's go this one. Like, look at that. You have a bunch of asynchronous steps, and if you're not using promises, you will end up with something that looks kind of like this, where things just start trailing off to the right side. And it gets really hard to read and reason about. When we use promises, we're able to sort of structure them as do this, then do this, then do this, then do this. And if anything goes wrong along the way, catch it.
And with promises, you always return an asynchronous function.
It'll always, it's guaranteed to be asynchronous. So let's talk about promises. Promises are about the idea that we will have a value eventually, but not yet. Promises are guaranteed to be asynchronous, meaning even if you set up a promise, your own custom promise, and it uses purely synchronous code, it will still resolve asynchronously.
Can you dive real quick into the definition of like asynchronous, just so
For sure.
I keep getting it confused? Thank you.
For sure. So let's use the example of the call stack and the event queue. So JavaScript just runs things line after line, but JavaScript's not the only part of our environment. the JavaScript runtime also passes things off to the system. And so you can think of things being passed over the fence from JavaScript land over to the system. So on this side, we've got JavaScript land. On this side, we've got the rest of the system. So JavaScript itself is synchronous. But the system is asynchronous, meaning it can do multiple things don't necessarily happen in the same order. So whenever we're doing callbacks or certain synchronous things, we are asking the system to do things on our behalf, like talk to the network, access the file system, set timeouts. And the system says, cool, we'll notify you when that's ready. And because the JavaScript can only do one thing at a time, what the system has is something called the event queue. And this is the line of things waiting to be run, one after another. So when I toss something over the fence, I don't know when it's going to be done. I don't know when it's going to come back, and I don't know what position in line it's going to get. So when we say asynchronous code is something that throws something over here to the system, and we don't know when the next part is going to come back in line. And this is what our callbacks are. Our callbacks are the things that are waiting in line for them to happen later. And so the JavaScript code we write is synchronous, but when we say it's asynchronous code, it means that we're throwing a task over to the system and we're not sure when it'll come back onto the JavaScript side to be executed for us to work with in our code. Does that help? Awesome. So that's one of the big things with asynchronous stuff. Now, the way that we write callbacks is we kind of have a callback and it kind of needs to handle everything and it needs to know about everything else. With promises, what we would prefer to do is we would prefer to think about the value and just say like, yeah, after I get this value, then I'll do something else. We don't want to encode in the callback what you have to do. We don't want to have to tell it. We just want to say, give me back an object. And when it resolves, I'll give it a method to tell it what to do. So we want to tell it what to do out here, outside of the value, outside of the process of going and getting it, instead of embedding it directly in there. Cool. So let's look at some promises here. So what we do when we promisify something is if we have a function, beforehand, we would have to write once you get the value, what you do with it has to be embedded in here, inside of that function. We want to flip that so that we can say this function will just, in a sense, return the value for us to use. So rather than specifying in here what we want to do, we want to have something that var promise equals something. So if I call this ASDF, I just get the value ASDF, and then I'll say promise.then, and then specify what I want to do with it later at the appropriate point in the program, rather than having to specify it immediately at that point. So it's a structural change. You're not fundamentally doing anything different, but you're allowing us to organize what to do with the results into a more coherent place. And you'll see that especially when we get to await async. Now, promises are always in one of three states. Every promise starts out as pending. We don't have the value back. And then it's either fulfilled or rejected. Fulfilled means, hey, I went there and I got the value, here it is. It's exactly what you asked for. Or it's rejected, something went wrong. The network went down in the middle of your request and I tried to reach this resource, but I couldn't, so you can't use it. So promises are always in one of these three states. Either they're pending, they're fulfilled, or they're rejected. Now, we don't really worry about pending too much, but when something is fulfilled, this is what the .then function does. The .then function allows us to provide a handler for when that promise is fulfilled. Rather than just coding in directly what we would have to do after we get the value, we can instead set up something that kind of feels like an event handler for when the promise is fulfilled. Same thing with .catch for when there is a problem. We can say, hey, there was an error. Listen for this error. When that error happens, here's what you do. So it's almost like we have these two events happening. Instead of just getting the data back, we're listening for a got data back event before proceeding, which can be a little bit tricky. Promises are a little bit tricky when you run into them the first time, but the more times you use it, the more times you see the alternatives, the more you'll come to appreciate them. But they're a tricky topic to get across at first blush. We'll definitely be spending some time in office hours working on this. So let's go through and introduce or look at a full example. So you can kind of glaze over this if you just want to think, oh, this gives me a version of those functions that return promises instead of callbacks. You can limit it to just that understanding right now. You don't need to know the deep internals of how Promisify works. You just need to know that read file async and write file async, instead of using callbacks, return promises. Instead of using callbacks, return promises. Let's take a look. So we've say read file async, and instead of providing a callback here, I am providing it out here. So now I don't need to know ahead of time. I can pass this promise object around my program wherever I want. I don't have to keep passing and move that up instead of pushing my callback function further down into the depths of it. There's a lot of, you might think of it as you are able to eliminate a lot of plumbing this way, especially when it gets, as you get bigger and bigger programs. So we take that data. This is the data that we got from reading the file. We parse it into JSON. We go through and we push each one of these into their relevant array. So dogs go into the dog array, cats go into the cat array. This is just a for each loop doing it instead of our two filter functions. We make the JSON data and then we write them out. And in this case, this is a pretty direct translation of what it is. But the big thing to notice is the .then keyword. Instead of passing in a callback function for what to do directly, we're in a sense getting back these objects that we can add event handlers to that tell us, hey, this thing is going to happen eventually. Now, when we get to async await, that'll help clear this up a lot. This is kind of a middle step. So if it feels kind of tough, it is. But well, it'll be easier the more you practice with it. In fact, let's go ahead and do this next assignment together to kind of illustrate this. So this one's great. How many of you love a good dad joke? I do. So got a few hands up in the air. We're going to use icanhasdadjoke.com, which is a premium like mid-2000s URL, I feel like. I'm glad that they jumped on that one pretty quick. And so this is an example of what you can get from it. An apple a day keeps the bullies away if you throw it hard enough. Or I wear a stethoscope so that in a medical emergency, I can teach people a valuable lesson about assumptions. You know, different little jokes like that. So we're going to use this. We're going to send a special header that says, hey, don't send us back HTML, send us back JSON data instead. That's part of what headers can do, is say, hey, I don't want HTML like I get when I just copy this URL into the address bar. I want it specifically to be JSON data. So let's run this in console.log out what we get. So follow along with me. We're going to go ahead and open this up in the terminal. we're going to run npm install, get all of our dependencies, and let's run the program node index.js. And it says, here's our joke. Why was Santa's little helper feeling depressed? Because he had low elf esteem. Classic dad joke. We can run it again and we'll get other ones. What do you call corn that joins the army? Colonel. Wonderful, wonderful jokes. We have them. We must save these. And in fact, that's what the assignment has us doing. It says you should save all of these dad jokes that you get. And if we look at the README together, we run the index file, we see the random jokes that returned. What we want to do is append the joke property of the response data to a file named jokes.txt. After you append the joke, you can read from the jokes.txt file and print its entire contents to the console. So we're saving the results from each one of these that we get so that we can print them all out at any given time. So let's jump into index.js. So there is no file to begin with called jokes.txt. Fortunately, if we write it out, that's fine. We've got fs here. We even have append file and read file already ready to go. And what we want to do is append the file first. Let's think about this again in terms of our circles. The first thing that we need to do, visit the API. Visiting the API is our first asynchronous action. It's the first time we're talking to an external resource from the program itself. For this purpose, you might also think of files as external resources, but things outside of the JavaScript code is a good way to think about it. The next thing that we need to do is we've got another stage here where we need to actually take the information that was written and read it from the file. And only after we've successfully appended it to the file are we going to read out the whole thing and print it. So again, we've got this sequence of actions that we need to follow from one to the next. And so each one of these is going to be a promise that we move from one to the next. This is axios.get. This is going to be, the next promise is going to move on when we have done append file async. And then the next one will be the results that we use from read file async, and then that will technically move on to the end of the program. And so if we think about the stages, it's easy to think about these in terms of promised values that we need. So we'll start out. We've got the data. We need to specifically grab the joke out of it. Let's even do some destructuring on that. So const joke equals res.data. And we want to append that onto the file. So we're going to say append. So we're going to return this joke. Or we could just return res.data.joke. Let's do that instead. So if I store this, if I say var result, this is going to be equal to a promise in the pending state. And once the callback comes, it's going to resolve to res.data.joke. So I will have a promise that has resolved to the value of res.data.joke. From there, I can actually tie on more things. Result.then, so once that result comes back, what do? Well, then I want to write that to the file. So I can say, all right, whatever value that we got from resolving that, which in this case is res.data.joke, I want to append that. So I'm going to say return append file async. The first thing is going to be jokes.txt. We're going to append the joke. We'll just name it joke here to be more specific about what it is. And we'll store that result as well. So we'll call this Ajax result. And we'll use const here. Append result. And then finally const read result equals, once we've got the append result, then, and we'll go ahead and move this out of the way. We'll actually just delete it for now. Once we append that data, and then we're going to return read file async jokes.txt. And then we're going to take the read result and then console.log it. So you can see this kind of reflects our different circles. We combined them because we could chain them together really easily. But the first thing that we do is we get the result of the value from using Ajax to get the result. Then from that result, we get the result of appending the file. Hey, we appended to this file, and this is the promise that that's finished. Once that's finished, you'll notice we don't use the file result. We just don't care about what it gives us. We just care that it's done at that particular point. Then we read the file. And then after we've done each of those steps in order, we can console.log out the result. And so this lets us very clearly see one step after another in each of the asynchronous steps along the way, rather than a big long chain of things. We can break them down. Now, a lot of times people won't necessarily write it like this, breaking it out into individual pieces. Instead, they'll sort of get rid of the intermediate variables. So you'll just see Axios dot then dot then dot then dot then. So there's no intermediate values or names that we give to the variables. It's just do this, then do this, then do this, then do this. So we get the data from the API, then we append the file, then we read the file, then we console.log out the result of reading the file. And each one of these are a different asynchronous action. Questions so far? Cool. We're going to add one more thing real quick, and that's if something goes wrong, we're going to say there's an error. So if at any point any of these fail, the promise will be rejected, or the promise will have been broken, and we can't do the next step, so we'll jump down to catching the error. Cool.
Sorry, where do you use the read result?
So we get this result and we console.log it out. You'll notice that we don't care about the result of appending the file because we're just going to read from that file again anyway. So what is returned here is this next value. So whatever gets returned, like this res.data.joke, gets returned as the next step as joke. Whatever the result of append file async joke is file result. We don't really use it because it just says, hey, you appended the file. What we're more interested in is the timing, because we don't want to read the file before it's done appending. We don't want to read the file before it's done appending. Now, when we read the file, the result of that is right here, and then we can console.log out that result. And then at the end, if there's an error, we console.log that out.
So the function or the on line 23, that's not used.
Right, and this is the shortened version
Okay.
of this whole process. So these two do the same thing. This is just the shortened version of it. Right on. So, as it turns out, you can actually make your own promises as well. You don't just have to rely on what people give you as well. You can say, I will give you a value eventually. And when I do, you can tie into this .then .catch framework that lets you keep chaining together different asynchronous operations. I want to do this, then I want to do this, then I want to do this. If you ever find yourself describing something in English like, hey, I want you to go to the store, then when you're there, pick up some bread and some bananas, and then drop by the gas station to refill the gas tank. And you might not care about the order in that particular manner, but let's say that you did. You always want to make sure that it happens in that order. You would have a series of promises. So the first one would be go to the grocery store. And then let's say that once you're at the grocery store, you can just pick them up synchronously. And so you grab those two things. And then after that, you go to the gas station and fill up. And then if that, you come home. But if any problem occurs along the way, let's say the car breaks down on the road to the grocery store, you can't really do the other pieces. So it'll switch over into the promise being rejected, at which point you can catch your error and say, that's when you call home and say, the car broke down, can you come pick me up? Or something like that. So it's following those sequence of events. This is about asynchronous events, or traveling between different things. So I want to see an example of this right here. This is if we had to hand code the read file async function ourselves, and we weren't using a function to do it. And we'll review this again during office hours as well. So read file async, we're going to return a new promise. That promise can either resolve or reject. We always start out pending, and then we're going to call a function that's either resolve or reject. Resolve if we have the value that we need to use. Reject if something went wrong and we need to cancel what we were doing. So if there's an error when we were reading the file, we reject it. Sorry, this promise got broken. We can't read from the file. If it didn't have that, then we'll just resolve the data. So this is what the promise is doing. It's just shifting around the order. So we can say read file async. If it works, great, here's what you do. If it doesn't, here's what you do. And then we could chain these together. So if something breaks at step one, we're done at that point. It just stops. Versus if we had a big long chain of promises after that, and it all hinged on the file being read, if that happens, we just see the big chain of events and we can see, oh, none of the rest of this will happen, etc. Cool. So one last thing, and this will be kind of a preview of what we're going to talk about a little bit tomorrow, is I want to show you sort of what we're building towards. So let's go back to our joke saver. And you can see here that we kind of have these things one after another. And even then, it's still kind of tough to read exactly what's going on. So there's a special type of function you can write called a async function. And an async function, unlike regular functions, can kind of pause along the way. And it'll say, hey, JavaScript, just run me in steps. I'll tell you when to pause me, and then you can come back and do it. And really what it is it's promises underneath the hood, but it lets us write them in a way that makes it really easy to see what's going on. So let's call a function called getJokes. At the beginning, I need to say this is an async function. And what that async function means is there's asynchronous steps going on in here. I'm going to be using the await keyword to pause along the way. So be aware of that. I'm going to hand back control to you on while I'm waiting for the system to get back to me. So instead of writing it like this, I'm going to do a try catch around the whole thing. Try catch isn't exclusive to async await, but you're definitely going to see it. Whenever you see a try catch block, it says, try all of this stuff, and then if something goes wrong, catch it here, and I'll handle it down here. This is talking to the manager, if you will. We're not going to bother what's going on in between. We're going to handle any problems that pop up in that block down here. So what I'm going to say is, all right, the first thing that I need to do is I need to get the results from the ICANN-has-dad joke API. And I'm going to write that as const response equals await axios.get. This is the then value that we see right here, but it's written out so that it kind of looks like synchronous code. Kind of looks like, hey, we're just going to get this. We know we need to wait a while. The program will proceed forward once we have that value, unless it throws an exception, in which case we'll handle it down here. Let's continue. The next thing that we need to do is we need to append that new joke into our file. So we'll say, all right, the next thing we need to do is append file async jokes.txt our response.joke. Now, in this case, we're not using the value, or sorry, response.data.joke. Now, in this case, we're not using the response from the await, but we still want to not proceed until it finishes. So we just write await here at the beginning. We're not using the value, but we want to wait until that promise has resolved before moving on to the next step. And so next, after that, then we're going to read file async. Jokes.txt, and then I think it's UTF-8. Yeah, we need to specify the type that it is. I forgot to put that up here. So that's what I want to do, and I want the results. So I'm going to put await in front of this, and I'm going to say const, let's say data equals this. And then I'm just going to console.log out my data. And if there was a problem, console.log out whatever that was. Pretty cool. So let's call getJokes. So let's get rid of, let's comment out all of this. And let's run this file. See if there's any errors that we get. No such file open jokes.txt.
On line 43, you have jokes.text.
Okay. Yeah, let's do that. So we'll delete that one and try it again. What do you call a boy who stopped digging holes? Douglas. What do you call a boy who stopped digging holes? Douglas. What does a pirate pay for his corn, a buccaneer. And then we're just slowly adding our jokes to the end of it each time. In fact, we might say, hey, let's go ahead and add in a new line to it as well. So let's go ahead and delete that. Do you know where you can get chicken broth in bulk? The stock market. Did you hear about the guy who invented lifesavers? They say he made a mint, etc., etc., etc. Cool. All of this is asynchronous stuff. All of this hinges upon the promises stuff that we are learning. But once you understand what's going on underneath the hood, you can write code that looks really synchronous. Do step 1, do step 2, do step 3, those circles that we mentioned earlier. All of these are the results of promises. So this is the result of then up here, of me getting a result from the API. This is the result of this is me waiting until the append file async promise has resolved, saying I've finished writing the file so that now you can read it. Awaiting the read file async. This data is the result. That's the then. That's the promise that got resolved for that piece of data, and console.log out that data. To use async await, you have to work with things that use promises. You can't. So it helps to know the underlying thing beneath it. So that's what we're moving towards. It helps make the asynchronous code a lot easier to understand, and we'll have the chance to practice with that more tomorrow. But I kind of wanted to give you a bit of a preview of where we're moving towards, so our asynchronous code gets a little bit easier to handle. Cool. With that said, we're going to go ahead and open it up for office hours. I'll be answering questions around promises or anything else that came up today that was kind of tricky to deal with. We'll be diving into it more tomorrow, but also the TAs will be available for one-on-ones if you have any other questions as well. So with that said, it was great having you in class today. We're entering a part that can be kind of tricky, especially with the back end and how promises work, but I promise it gets better. You'll see. Cool. We're going to take just a few minutes to get set up if you have to head out. It was wonderful having you. I hope you have a great afternoon. If you're sticking around with us, it'll be great to see you then. So I'll see you all around in about 2 minutes while we get set up.
Anyone else getting some weird results back on that first section?
Ooh, sorry about that, folks. Took a little bit longer than I thought. But we are back, and it is time for office hours. So I wanted to open it up to just start out with questions from today. Once we're done with those, I'm going to kind of talk a little bit about more promises a little bit more, as that's kind of the newest, most confusing thing that we've probably started out with. But I wanted to open it up for questions. If it's on promises, feel free to ask it. I'll say either I'm going to cover that later or answer it right then. So don't worry about accidentally asking a question too early. If there are any.
I don't know if it's a question on promises or not.
Sure, that's fine. It's a question. That's fine.
I was following along with you on both examples,
Mhm.
and it's working out. I'm just trying to let the wheel spin for figuring out why it works. The only difference is that in the first part that we did on this example, when we have a console.log the result, I'm just trying to figure out what that result is referring to now that we have this whole long string of everything.
For sure. So you mean like in this section right here?
Yeah.
So result is whatever this promise resolved from the one before it. So this is read file async. So this results, if we named it a little bit better, might be like the file read result. So this is the string that we get back that represents the contents of the file.
Okay. And that's just the data, because I kind of just get back numbers.
Are you reading back what it is? Is it like if you open up the text file, is it just a string of numbers in there, or is it
It's the text file, I get the joke, but on the console.log of the results or the file read results, I just get numbers.
interesting? Maybe that's the ID or something of it, depending on what you have written there.
I mean,
But yeah.
okay.
Go ahead.
No, I don't know if it mattered or not, where it just says buffer and then a bunch of numbers and then 281 more bytes.
No. So
Yeah.
you might be reading from it as a buffer instead of from as a file, which can sometimes cause issues.
Okay.
So if you forgot the UTF-8 here, which I went back in and added, it just gives it to you as a buffer, which can throw it off too. So that would be my guess. So if you add that line right there, I think it'll work.
All right, thank you.
Other questions, folks? We'll go ahead and give it time for some more questions. But I'll extend office hours a little bit to cover some of this in more depth so that y'all have a recording of us going through it again. All right. If there's no more specific questions with y'all, then I'm just going to talk a little bit about promises. Let's go through some smaller, more direct examples to sort of help build up your understanding of what's going on. So I'm going to make a new folder called example.js, or we'll just name it example. And I'm going to make a new file, and we'll include an index.html, and that's just so it's easy to work with here. These same principles work on the front end, by the way. Async await is just not as well supported on the front end as it is on a Node.js environment. So the latest versions of Chrome will run it just fine, but the earlier versions might not as much. But that's just async await. Promises are much more widely supported than async await syntax. It's kind of built on top of each other, and some of the more advanced parts of JavaScript. So let's talk about what a promise is. A promise is an eventual value. And with that, we kind of get to what I might call pseudo events. The promise resolves, meaning we get the promised value, or the promise is rejected, meaning there was an error. It's a broken promise. We weren't able to keep our promise. And what we do is we say, once one of these happens, what do? When we have a promise that resolves, this can itself issue a new promise, which we can keep chaining off of. So if it's a catch, you can technically do that too, though you don't see that as much. So a lot of times you'll see promises chain one after another, just like we saw. Let's go to the API, let's write out to the file, and then let's read from the file once we've done all of that. So it's a series of asynchronous events, but we need to wait in the proper timing to do it all. So an example we might think of something that takes a while is, what if we just wanted to wait a set period of time? What if we just wanted to wait 100 milliseconds? So we could say something like set timeout, and then we have some function, and then we want to take 100 milliseconds. Great. This accomplishes our goal, but it's not very flexible because we want to write something in this particular way. What I would love to do is write a function that will just wait for 100 milliseconds and then resolve a promise that says, we're done. Good job. Here you go. And then I can just use that at any point in my program. Let's say that I'm making like a slideshow program or something like that. And I just want to pause, or I want an animation to occur, and then after that the animation times out. There's a whole bunch of reasons I could want to wait a variable amount of time. And I would like to do that in the promise format, because that way I don't need to say set timeout, whatever, function, and grab all of this stuff. I just say wait 100 milliseconds, then do whatever you want. Wait 100 milliseconds, then do whatever you want. So I'm going to write a function for this. So I'm going to wrap it in a promise. So I'm going to say function wait. And our function wait is going to take a number of milliseconds to wait. And what it's going to do is return a promise that resolves after the amount of milliseconds that we were told to wait. So I'm going to return a new promise, and that new promise gets a function, and that function receives two parameters, resolve and reject. These are two things which we'll call within our function. So we're going to kick off whatever process that we need to, any asynchronous process, and then when we're done, we want to call either resolve or reject. If it didn't work for whatever reason, we're going to reject it. So we're going to call set timeout, and we're going to say, all right, however many milliseconds we want you to wait, and then we want you to resolve after that amount of time. We don't really have a reject case in this particular instance, though we might later. So how would we use this? Wait is now returning a new promise. We'll talk about new more when we talk about constructors in more depth. You might have seen us using that in the Crystal game a little bit today from when we reviewed that. But this gives us a new promise. So I can now say wait 100 milliseconds and then do something. So console.log, let's say 1. And then I could say, go ahead and wait for another 100 milliseconds. And then, and you can kind of see where this goes. So wait 100 milliseconds, and console.log out 1. Then wait another 100 milliseconds. Then console.log out 2, for example. And you're starting to see this is kind of a nice ideal way to read it of wait 100 milliseconds, then console.log out 1, then wait 100 milliseconds, then console.log out 2. These are the different series of things that we can do. This one will resolve very quickly. So let's actually change this up to be a full second. It'll make it a little bit easier to see when we run it. But let's go ahead, open this up in the browser. Open up the inspector and we'll refresh the page as we do so because it's been 2 seconds. So if we look in the console, we see 1 and 2. So wait, 1, 2, one right after another. It should be waiting. Okay. So it waits 1 second and then it doesn't have anything. So we're not returning any values or any promises right now. So it's getting undefined. So it should be tying those together. So what I'm actually going to do is the following. First, we console.log 1, and then we're going to return a new promise in its stead, which is return wait 1000 again. We'll take that out here. One, 2. There we go. So it's waiting for one promise, then we return another promise for it to use, and then it uses that, etc., etc., etc. So that's how promises work. They will give us a value at a time in the future. And you can think of them as almost like an event handler. Wait for when this finishes. Now we also want to handle if something rejects. And I'm going to model that as a random function. So if math.random is less than 0.5 or less than 0.2, let's say, there's an 80% chance this thing will succeed. But there's a 20% chance that it'll fail. How do we handle that? We don't know. Much like in real life, we don't know when something will break or not. So we need to have a way to handle that. And so we'll say console.log something went wrong. So we wait a second, something went wrong, the rest of it doesn't proceed. Our original promise was broken, so anything that changed off of this program or that promise won't continue. Our trust has been broken in a certain sense. Any questions about what we've kind of written so far?
What is initializing that error above? You put that if it's greater than or less than 0.2. I'm just wondering why it threw that error.
Basically, I randomly choose, hey, actually it's a really, if this is, let's do it this way. There's an 80% chance that it will work. Otherwise, it won't. So resolve means it went successfully. Reject means it did not go successfully.
Okay, and so those aren't actual functions that are defined anywhere. That's resolve is a set function of it went okay.
Well,
And
these
with-
are the two parameters that you get passed up
Okay.
here. So they come from resolve and reject. So you could name these whatever you want, but they're usually called resolve and reject, and that's the function that they have.
And you would have to change the names in the if and else statements as well.
Yes.
Okay.
So those are being passed to you from the promise constructor. When you make a new promise, that promise constructor is going to pass you, hey, here's how to resolve, here's how to reject something. And you just call them when you would. And something you could do is resolve a value. Like you could resolve the number 2, for example. You're like, hey, guess what? It's going to be 2 every time. And then I can use that value and console.log it out. Or I can not use that value. So in this case, it resolves the number 2. It could resolve an object. It could resolve an array. It could resolve any value. That's just going to be the thing that you get when you use the then function, like an event. So let's run this, and let's make this one kind of obvious. It'll resolve, what about Bing Bong? Let's refresh the page. 1, what about a Bing Bong? That's the value that it resolved, so that's the value we used. So set timeout is basically just simulating a network call for us at this point. It takes some amount of time. We're saying about 100 or about a second, and then some data comes back to us. Same idea is happening here. We just made a custom promise for it. Now, if we want to use async await with this, we can make it even a little bit clearer, which is nice. So I'm going to write a function. I'll just call it main. And I'm going to say try. When I use async await, I kind of lose the catch here. There's no real spot for it. So I have to wrap it in this try statement that says, hey, please try to do this. And if there's any errors, they instead get caught down here instead of in this special .catch block. So what I'm going to say, and we're just going to translate this into here. First of all, mark it as async. That way JavaScript knows, hey, this function has awaits in it. And we're going to say, all right, await, wait 1,000 milliseconds. Now, for this first one, we're not really using the result, so we could just leave it like that. We're not doing anything with the value it gives us. So after that, we're just going to say console.log 1, and then we're going to use this next value. We can see that down here. So I'm just going to say const val equals await wait 1,000. And then we'll console.log out what val is. So you can see we're awaiting for the then value. Await is assuming that the promise will resolve. And it's waiting until the promise resolves correctly and gives us a value. Now, this doesn't handle if something goes wrong, like it does with the catch statement down here, which is why we have this special section down here. And let's actually give those the same names so that we can say console.log error. And this looks a lot like asynchronous code. Wait a second, console.log 1. Wait a second, get whatever value that it gives you back, and then console.log it out. But all of this is built off of the back of promises. If you don't have this underlying promise structure, you can't use async await. It won't work. So let's comment out this one, make sure that I did it correctly. We still need this wait function, and you're still using those under the hood. And there should be a 20% chance that it fails along the way. Let's see. Oh, I forgot to call it. Let's kick off the main function. One, what about a bing bong? Let's refresh it a couple times. I'm sure we can get an error in here eventually. Yeah, one, and then undefined. We got that error because we didn't reject a specific error. We could reject something went horribly wrong. So let's try that again. We get something went horribly wrong the first time because the promise rejected, because there's just a 20% chance that it doesn't work. Don't write functions with a 20% chance they won't work, by the way, if you can help it, right? Especially randomly for no reason. But it's good for simulating something that is unreliable. So sometimes it works, same code, sometimes it doesn't. So that tells you a little bit more about promises, the 3 states that they're in, and then how you can sort of use them once you get data back from them. What's in the promise, that's up to the library that you're using. Axios gives you back this response object that represents the response you got from the server. If you use the promiseified version of the file system utilities, they'll give you back data from disk or just nothing if it's a read or if it's a write file. So promises are just a structure for managing this asynchronous process. They don't necessarily inherently tell you what is in there. It could be anything, just like a variable can hold anything. Any other questions? Everyone's just going, I need to stew and think on this for a bit.
Is there a reason why the writing code evolved this way? I understand it's a little bit simpler, but I don't know if there was a specific reason why it goes this way. Is this just kind of the way that everybody writes code, or is there some places that are a little bit more simplified?
So this is kind of the simplified version, and as you get in, like, we're kind of working with toy examples, you know, to an extent where they're really small, and when it's like 4 lines long, you're like, this seems overly complicated. It's when you get into these much bigger structures that it becomes really helpful. So the idea behind a promise is really powerful because you can just move that promise anywhere you want. You can return it as a function result. You can just pass it back and forth between different things really easily. And whether it's resolved or rejected, it'll just handle that when it gets the opportunity. As opposed to callbacks, you have to kind of shift them to the exact point when the promise resolves. So in terms of organizing a program, it became a lot easier to deal with promises where you could kind of ship around the idea of the result rather than trying to combine the result of, or what you wanted to do with when it was successful with the thing itself. So things definitely moved to be much more promise centric rather than just pure callback centric. And you'll notice these promises are still using callbacks. It's all just about not having raw callbacks where it's just do this, do this, do this, do this, do this, do this, do it, and do this big chain of things. The more and more you work with bigger projects, the more you'll get a good idea for it. It's kind of hard for me to communicate it in small examples like this. But it's really about how well these kind of things scale up as well. Because asynchronous code, guess what? With websites, it's everywhere.
It's definitely getting better, because when you ever look up and you try to look up an example of something for like homework or the project, it's normally stuff like this. I've seen the try, the catch, and a lot of more then functions. It is nice to see them now that we're learning them.
Absolutely. Yeah, so those are going to be just out there a little bit more. If you want to jump ahead, you can peek at 38 and 39 that have some of that. That will be going over tomorrow, and then there will also be a little bit of a mini project that to help you solidify and work on that, and then we'll be publishing a solution for that to sort of help you towards your homework. But we'll be practicing that tomorrow morning as kind of a way to practice your homework without actually doing your homework, but allowing us to give you feedback and correct it and go through the process with, and then you get for your homework to do it yourselves. And then we get to talk more about constructors. And so when you see the new keyword and stuff like that, you'll have a little bit better idea about what's going on. But yeah, promises, really powerful stuff. And in terms of writing a bunch of asynchronous code, you'll still use it a ton. We saw it yesterday in the other office hours I did, where we are like, hey, let's go ahead and get all of these different movies and then get their values and work with that. So we had code that looked like, let me just, so we could say something like const get movie. I can say, all right, I'm going to write a function that's just about getting a movie from the OMDB. And let's grab this Axios CDN link. Axios will also work in the browser, which is a nice thing about it. There we go. So we'll copy that. Type equals text JavaScript, and the source is equal to this. Cool. So now I can use Axios in here. So I'm going to write a neat little function called getMovie. You give it a title, and what it will give you back is a promise of that movie. So we're going to say return axios.get. Let's format the URL. The URL is equal to https dbapi.com $t equals title and API key equals trilogy. Axios.get that URL, and we'll just and then we'll say .then we'll just return the data from it. Neat. Now I have a function that is just going to return me my movie data. So I can say get movie, remember the Titans, then console.log, you know, the different pieces of it, like response dot title, response dot year, response dot plot. So somewhere my API team wrote this function. I don't need to care how they got it. I just need to know the structure of the data that I'm working with. So let's run it. Assuming everything worked correctly, which is always a big assumption with my code on the first try. Remember the Titans from 2000, and then there's the rest of it there. Cool. Now I could actually do this for a whole bunch of movies. Let's say that I have a bunch of movies. So I say const movie list equals remember the Titans. Frozen, Die Hard, how about one more?
Speed Racer.
Speed Racer. Cool. So now I'm going to work with some of my other functions here. So I'm going to say async function display movies, and I'll take a list, and I'm going to call that display movies with my movie list. And I'm going to say, hey, my list, wherever I got it from, whether it's local storage or whatever, I want to save it. And this is the list of movies that maybe my user has saved. So I'm going to say list.map, or let's actually say await, or no, const movies equals await promise.all list.map movie get movie. Well, really, it should just be get movie. We can simplify that. And then we'll say document.query selector. We'll actually save this one out here. Equals document dot. Actually, we'll find a thing on here. We'll use a div. If I can type, there we go. Document dot query selector div body dot inner HTML equals, and this is potentially dangerous, but we're going to do it anyway. Use dot map movie return, and we'll pull out all the pieces that we want, like the title, the year, and the plot. And we'll just return a little div in there with a h2. Dot join, by the way. Dash I don't know, something like this. So now we've got, if we follow this, display movies, get my list of movies, and then change this thing's inner HTML. Or let's change this to be $div to keep up with the name, to be this movie list. So now if I save this and refresh the page, machine initializer and destructuring declaration. Yeah. Whoops. There we go. And then if I can type things correctly, always a travail with this one. And then we got undefined, undefined. I think Die Hard is technically 2 words on here.
So Speed Racer.
And then we have undefined in the list for some reason. Speed Racer, I
Space
guess I
Racers.
can't find it. Let's try it. There we go. And then I could say, well, actually, I want to find all the movies that belong to a certain genre. And I could go, oh, cool. Let's go ahead and grab a piece before then. Let's write let's say it's a function, find movies, title, and we're going to say, we'll make this one async as well. Let's go ahead and try find movies with, actually, let me change this around. I'm not going to go that deep into it. We'll change it. We'll do it. So ID ID let's take find movies. Let's say that we're looking for all the Star Wars movies. And let's say that we say const search movies equals title. It's going to be very similar to this one up here. And we'll say search. So we'll call const movies equals await search movies title. And let's just console.log out what movies is first. Okay, and we'll return back this.data.search. Cool, there's the array of our movies based off of the title. And it also includes their IMDb ID. So we're going to say display movies, movies.map, m to m.imdb ID. Await. Oh, that we don't need that one. Yeah, that's fine. Console.log. Done. Ooh, ran into a problem there. Let's figure out what it is. Let's console.log out the movies. My suspicion is, yep, IMDb ID has a capitalized D. There we go. Bunch of Star Wars movies. We could even tie it into, a button or something. So actually, let's just do that as the last thing we do before I let y'all go.
So you just created that search function and then had it run back through your initial function that you had for searching for a specific title that had already set up a...
Yeah, so this is one network search, and it says, and then I can just use that in the rest of the program however I want. I don't need to pass anything. I just say, yeah, await this till you get it back, and then you can use it however you want. rather than here's this callback, I'm going to pass deep into this other thing. So let's input ID equals movie, placeholder equals movie. So we'll go ahead and say this. Input query selector. Well, we could really just find it because there's only one input. These are bad names, by the way. Don't use div input and button, use IDs and stuff like that. We're just doing it for speed at this point. So we'll say, all right, hashtag button dot add event listener click function. And this is a case where we do want to use function and not an arrow function. Well, actually, either one will work. We're not going to use this, so it doesn't matter. But most of the time in event listeners, you want to use a regular function. And we're going to find the $ inputs value. Technically, we could use fetch so that we didn't have to use any external libraries, but we're not going to. Because I don't want to deal with that right now. I think that'll be all right. This isn't structured particularly well, but let's find out. All right. What movie do we want to look for? Hopefully something with a lot of results.
Star Trek.
Star Trek. There's a couple of those, I'm sure. So let's click search. And there's the first 10 from that. We could put in Transformers and get all of those. And it's not a stupendous amount of code. And it's pretty easy to add in other stuff. Like if we wanted to put in the poster, we could just do that right here. Make sure we include those. Let's try Transformers again. And you're on your way. So you've got this neat template right here of getting all of the movies. This is probably a little too tightly coupled. You probably shouldn't have the network request and the render code tied together like we do here, but it works. Let's clean this up now that we've got something working. We'll put all of our constants up at the top. We'll put our little Ajax requests up here. I'm actually going to pull this out into const get all movies. Yeah. List IDs. Return that. All right, we'll change this around. And now this thing doesn't need to be async anymore because we pulled that piece out. So now we'll come down here and we'll say const IDs equals await get all movies. Cool. So what we do when we click Find Movies is we're given the title. We then get a list of IDs. We then get all the movies associated with that list of IDs. And then we display the movie based off of, actually this should just be movie data, movies data. Let's see, search results would be a better name here. And then we'll call this render movies. So this is very closely following what I do when I program, which is I think of a better name for it that's more descriptive of what it is, and I'll actually go back and change it. And you can also see some of the perils of doing that because I'll forget stuff and be like, oh yeah, I changed that, which is why we always come back here and try it out. The matrix. Reference list is not defined, see already. So on line 30, I changed that to be list IDs to be more accurate. Let's say Indiana Jones. We'll click search. And there they all are. And in a sense, it would be easy to start splitting these up into different pieces. Hey, these are pretty independent. They just need to use Axios to make network calls. This is pretty independent. If I'm working on this independently as a HTML, someone working on the HTML, I just need to know what the data looks like that I get. And I can generate this. If I find movies is kind of the only place that is binding these all together. The rest of these could be broken out into other things for me to work on to be able to be tested independently, etc. But yeah, these are just API things, etc. So I might even leave a comment up here like API methods, HTML helpers, button click, event helper, event handler. So you click on this, you go to find movies. You search for all the movies, you get the search results. You take the search results, and you get all the movies based off of the IDs. In fact, by ID would probably be a better name for this, as it will communicate more about how we're actually using it, even though the list IDs is set up there already. So, I don't know. Well, I've been blathering on for quite a while at this point. Thank you all for indulging me. Any final questions I can answer for y'all?
How come you didn't want to join Project 10? You just did our whole project in about 15 minutes.
Been doing this a long time.
Yeah. No. It's nice to see that's kind of what you're shooting towards is. Yeah, it's nice. We got to the same thing that you did, but it just took like a day.
What you don't see is the many days in the background where I screamed at my computer, why? Those are just behind me. That's the difference.
I recorded our sessions. If you want to see that, I've been doing it for a while.
I love it. I love it. But yeah, and you'll learn how to do it as you just get better with your tools. You'll see this with anything where someone who's been doing something a while just is faster on it and can catch the errors more quickly. So the big difference is just time and time on task and how much I've worked at it. You might be a little weirded out if like a decade later I'm like, and like the exact same place as you guys are. So you can speed up quite a bit.
Good question, Eric. Are you gonna be posting this in office hours?
Yeah, I can post this in office
Cool.
hours.
I get the why for this coding. It's the how and writing it out and what to use where that I seem to be having an issue with.
For sure. So let's talk about that. So we're blank paged and we're facing a blank HTML document, and we're like, okay, cool. What do I do? Okay, I want to display movies on the page. Cool. What do I have? And so you look at your API, you look at your available APIs, and you go, okay, what do I have? And so part of that process would be just exploring the APIs. What can I do? My goal, let's annotate this again really quick. My goal is that I want to display a list of movies related to the search. Now, looking at our API, we discovered it's kind of limited. We can kind of only search by title. We can kind of only search by title. We can't really do much with genre or actors or other things. The API just doesn't let us do that. And so we're limited in some fashion by that. Later, as we build our own things, you'll start to see, oh, we can actually structure our data so that if we have that data in our database, we can vary that up. But this is just by title. By title. So I can look at the API and go, okay, I can search by title. That's something I can begin with. But I also know I'm going to need to talk to that, and then I'm going, what information does that give me back? Ooh, it doesn't give me back all the information I want. Doesn't really give me the plot that I want. It gives me like a title, a year, and an ID. Well, hey, that ID lets me target exactly what I want in the API. So now I can start imagining a series of events, because at the beginning, I just need to get that data. I want the movie poster, the title, and the plot. Movie poster, title, and the plot. So I know, okay, well, that's going to be at least one network call at the beginning, and then another network call per each one of those, which you could have done with the techniques that you know from one, but it would be a lot more painful than this in terms of just getting all of those different pieces of information and timing when all of them came back and things like that. That's the part that we're simplifying a lot right here. Is the promise.all is a real quiet, heavy lifter to say like, oh yeah, we made all those requests and now they're done. That's a really big task that's kind of hidden behind there. So what I like to do is kind of look at these as a sequence of events and try and draw the stages like I was talking about earlier. So the initial API call is going to be, let's go talk to the OMDB API, get that movie, or get those list of movies, but they don't have all the data we want. So I'm actually going to need to do like a bunch of these little ones at the same time. And then once those are all done, I can display it to my user. These are great fodder to be their own functions. So this is the function that kicks it off. It's going to call some other function or series of functions that handles each one of these. And this can be its own function. And that's kind of the pattern that we see here of do this, then do this, then do this. And we kind of just have one big function to structure it together in what we were just looking through. So we have get movie or search movies. That's our first one on the left. We have get movie. Those were all those central ones in the middle. Now you probably, without knowing about promise.all, you might have had to look up more or figure out a structure of doing that. Hopefully you would have just arrived on promise.all, but now that you know it, it's in your quiver, you can use it. And so you say, okay, I want to call a bunch of these, and this get all movies by ID is what it was, that bigger circle around it that sort of said, hey, I want to do this all and then just run this. So now, and then render movies is its own separate thing. So you kind of have each one of these as steps along the way. And then we have find movies, which is just about stringing all of those together. If you don't want to use async await, it would be blah, blah, then blah, blah, then blah, blah, or it would be a series of nested callbacks where you would say, all right, let's do search results, callback, movie data, callback, render movies, etc. But building them into these function formats kind of gives us an easy idea of, hey, what are the steps along the way? And an easy function boundary is when you have to do asynchronous stuff. You can have smaller boundaries, for example, like I decided to put render movies, and render movies actually doesn't need a wait in front of it anymore because I pulled out that part. So I separated rendering a bunch of movies from the actual retrieving the data for those to help sort of keep those separate, because now it's really easy for, let's say that you and I are working on this project, Stephen, and Corey is also on our team and he's doing the API portions. And so he's working on just getting the movies back from the database and based off of what we want. We know what they look like. We know we have an array of these different movies. And maybe design comes around and we're like, you know what, we can only look at one at a time. So we're going to have it, you click a button and it goes to the next ID in the array and it loads it up. So you can also design around the problem where it's like, click the next button. It's like, cool, we'll load in the next one. Click the next button, we'll load in the next one. If you don't necessarily have the key to it. But the important thing is Corey could be working on this and his code, the code he's typing, won't overlap with our render code if we're writing it well. As we just assume, we've got this list of movies. We know the raw structure to them. We know that they have title, gear, plot, and poster. So I could just fake that. I could just say, all right, yeah, I've got an array that have all of these different pieces. And because we've looked at the API, I know I have all of these. But it lets me just work on that function sort of in isolation. Because this function, especially the render function, is purely a function of its inputs for the most part. We're technically reaching outside of its inputs a little bit with the div here. But it's a relatively pure function. And so it builds all of this together. If you were being a real stickler for it, this render movies would just make a string, and then out here in this other function, you would take that string and put it on the page. But the idea of a pure function, a function that is just the product of its inputs and nothing else, if you give it the same inputs, the program will be in the same place, is another idea there. So I don't know if that helps you in terms of how do you structure it at all, but
it does, because it definitely is nice seeing after you kind of drew it up, and then the annotations on the actual code itself is nice because it's very visual of, yes, this is what I have, what I'm looking for, this is what I get, this is what I want to show, and then kind of showing that on the JavaScript of, here's the function so I can get what I'm looking for. Here's how I want to show it to the user, and then that event handler of like, hey, that's I think that's where I was kind of a little confused, is the event helper part where it's like, hey, here's why we're using this and how everything flows and calls all those functions.
Yeah, it sort of just orchestrates all of those steps together. And that way it's really easy to shift this. So if it's like find movies from something else, it's really easy to take that somewhere else. So it's like, yeah, okay, as long as you have a movie that you want to know more about, the rest of the program flows. What that movie's a part of, whether it's a button you click on with that title already on it, or it's an input box, super flexible. And it's, when I first started programming, I didn't know how to do all this stuff. So like, it's just a matter of doing it enough times and going through it a lot of the times and practicing your craft and watching YouTube videos and reading blogs about how people do all this different stuff, going through courses like the one you're in right now, that helps you build up all of these different things. No one just, oh yeah, I just emerged out of there and I know how to do it. Like it's all this accretion process of going through all these learning experiences.
Is there a time frame at which people kind of either steer towards a front end or back end developer, or is it moving towards full stack for a lot of people?
Almost always you have one that you tend to gravitate towards more. But it's definitely fine. Like I definitely still bill myself as a full stack web developer, even though I think I'm probably a bit better in the browser than I am on the server. So, and there's a lot of nuance to it. There's a lot that goes on in browsers and different things. Front-end developers tend to focus a little bit more on like the users and their experience of it, and back-end engineers tend to focus more on it, building the systems that enable those interactions. So that can sort of give you an idea of which way you might want to go more towards. But everyone, like you're going to be kind of expected to at least be proficient with everything, and you'll specialize towards more one or the other. You're rarely going to be like, I'm a front-end developer, which means I don't write any back-end code. Like that person doesn't really get employed. It might be like, I can write a little bit just to kind of get it started, and then eventually the experts will take over that part, but you should at least be proficient with it. So there's no like pure front-end developer, pure back-end developer. There's a few more pure back-end developers, but it's really more full stack, and then where are you specializing along the stack? I don't know if I've given this example before, but for the most part, and this is my advice to a lot of people, you want to be a T-shaped developer. A T-shaped developer. You are pretty good or decently good at a lot of things, and you're really good at a very small set of things. So you're not going to be good at everything. There's no developer that looks like this. They don't exist. And what people also like to think about is this is a threshold. This is when you're good enough at something that people will pay you to do it. And so you need to have at least a few skills that cross this threshold. But then everything else enables you to do better and interact with other pieces of the project. So maybe you're like, yeah, I'm a front-end developer, but I'm good enough to work with the database and the server side that I can get it done, but I'm good enough at the front end that people will pay me to do it, and this is value add to help distinguish me from like other people. Because if like I'm like here on databases, and then someone else is like is maybe better at databases, but they're like this across the board, they're never quite good enough at any one for them to get done, then it's kind of like, well, sorry. So you want to have something that crosses you across the threshold of I am good enough at this that people will pay me to do it for money, and then you can start expanding skills around that. Generally, you want to be able to talk to the layer above you and the layer below you. And if you're at the top or the bottom, that'll be 2 layers up or 2 layers down. So you want to have 3 layers of competence. So if you're a front-end developer, your layer of competence, and it's not always tech. You might be like, I'm an amazing front-end developer, and I'm okay at design and UI and talking to designers and stuff like that. And I'm okay at working with these back-end services, and I could stand one up if I needed to, but that's really not what I'm best at. Cool. There's your home. That's where you're making money. You're pretty good at this. You're okay at this. You're good to go. Versus if you're like, hey, you know what? I know I took a little bit of Python. I took a little bit of Java. I took a little bit of C#, JavaScript. Like at this point, you're kind of trapped in what you might call tutorial hell, where you know like a little bit about a lot of stuff, but you haven't ever extended the expertise to where people are like, oh yeah, we should pay you to do something. So having a bit of focus where you're actually working on these, doing your own projects, getting good with one stack is more valuable because people see that you can develop the expertise. And like I've worked for companies where like they were a shop where their backend was in Ruby, and I'm like, I've never programmed Ruby before, and they're like, that's fine, you'll learn it, because I was good enough at the other stuff to do it. So like I came from a C# background, and they're like, well, it's object oriented, it transfers enough, and I had good front end skills. So having one of these can help carry you over as you develop skills, and this isn't static. You'll get better at different things. Technologies come and go. But overall, I still recommend being kind of T-shaped. Pretty good at a lot of stuff, really good at a thing or two. Rather than jack of all trades, master of none. This is kind of the compromise between the two. So you're not this guy who's amazing at one thing. And some people make that work for them. There's like the guys who are like, hey, guess what? I really deeply know how GPSs work. And I'm like, cool. You can work for like 5 companies. And that's kind of my strategy on that part, is to make myself, and that's more just where I'm at. I'm not necessarily gunning for the highest paid position of all time. I'm more like, hey, I want to have a good work-life balance. I want to make enough to support me and my family, and I don't want to work myself to an early death. Is kind of where I sit on that. So that's how I bill myself, to kind of give you the context of where Eric's coming from when he gives this advice. And as always, it's just my advice. Other people have other advice. Take everything I say with a grain of salt.
Cool. No, I appreciate it. You always take everybody's opinion.
All right, with that, it is 3:40, and I got another class I'm helping out this evening that I gotta like eat dinner and get ready for and stuff like that. But it was wonderful talking with you, gentlemen. I will see y'all on Thursday. Good luck with the homework. I would recommend getting a start on it just so that you can ask questions of us in morning office hours and afternoon office hours, and we'll have that chance to respond to you. So have a good one, gentlemen. I'm going to go ahead and shut the meeting off. Have a good one.